Okay, so this is the demo for my distributed computing assignment. So to explain a little bit of what I'll be doing, I have a simple stockbroker sort of implementation where you'll be able to have users uh, and they will communicate with a management service that holds the stock and they'll be able to buy and sell the stocks. I'll be doing this using Postgres and RabbitMQ. So the first thing I'll need to do is get my Docker containers up. I have a Postgres and a RabbitMQ Docker container, and we should be able to see right here loading up the RabbitMQ management. Uh, there we go. And Postgres is on port 8000, while RabbitMQ is on this port right here. And then I will need to basically start the orders API using Unicorn right here, which you can see pops up the message queue on RabbitMQ. And to explain the workflow for this a little bit, I will have three different services going: a risk service, a matching service, and a settlement service. Um, which all do their different things. The risk service basically listens in to the orders API to find and classify orders. What this will do is it'll take in an order and then determine whether the order is valid or not. So whether the user has the money or the stock or whatever it's trying to do, it'll either accept or reject orders based on their validity. This will listen to accepted orders, the matching worker that is, will listen to accepted orders and will assign them some variables like who the buying and selling user are, as well as various other things about the order. And the settlement will listen to the trades that need to be settled and it will commit them to the Postgres database. So these are all running now. And I am going to start out by taking this just SQL script that I have. And what this will do is essentially just establish some users, the market management, as well as give the users some stocks. This will also go through, and if we go into the Postgres database and then we run it, this will wipe out whatever was in the database before. This is just for this demonstration specifically. And you can see it creates the users as well as gives them their stock positions and also establishes the amount of cash that each user as well as the market management has. So it's worth noting this market management is basically given a essentially infinite amount of stock. That's obviously not how it works in real life, but it's set to a very high number just for the purposes of this demonstration. This obviously isn't how it would be implemented if this were working in the real world. So now getting back here, we can go ahead and look at our exec. These are just different command lines running the different workers. And if we invoke a service, the balances service, we're going to invoke all. You could do this for specific users, and it'll pop up the specific users what they have that's stored in the Postgres database, but I'm just going to make a pretty looking table for all the users. So if we do that right there, you can see for each user, we see the amount of cash they have as well as the positions and how much of the stock they have. So this is what I will invoke next, and this is the bread and butter of this service. As you see, we're going to invoke REST method, and we're going to post to the Postgres database, to the orders API. We are going to include the user ID, what side of the deal it's on, so whether it's buying or selling stock, the amount of that stock, as well as the symbol of that stock. So this will go to the first user and it will buy to Microsoft. So if we run that, we'll see if we look on our um, database, should be able to see queues, orders accepted. We had a spike there because it took in the message and it accepted the order. There's the spike right there. And if we go to risk, you can see that risk accepted the order, Microsoft to buy user ID. Once Risk accepted it, matching basically matched the price, the buy user, the sell user, as well as the symbol and the quantity, and gave it a unique trade ID for logging purposes. And the settlement um, settled the cash after and the position after for both the buyer and the seller, as well as use that trade ID to kind of give a printout so that we can see what's happening. So user one just um, bought to Microsoft. So we see that in our Postgres database that user one now has to Microsoft, and we see the management service has increased the amount of money they have as well as decreased the amount of Microsoft stock they have. So now what we can do is we can sell that Microsoft stock back, and we will see it updated here as well that user one now has 0 Microsoft stock, and the numbers went back to before the user had bought it. So this uses some hard-coded stock data of the stock prices for the top 10 stocks, just to limit the scope so I'm not dynamically changing the stock prices, and the prices were gathered on October 4th and rounded to the nearest dollar. So now, obviously, users need to be checked if they have the money or the stocks, if they want to buy or sell stocks. So we're gonna take user two and we're gonna sell 1 apple. And you can see right here, user two had 1 apple and $2,000. And if we print out our table again, it gets the money from the Apple stock as well as loses that 1 Apple stock it has. So what if now we are user two and we try to sell another Apple stock? Well, you'll see our risk rejects that because if we print out the table again, you'll see we still have 1 apple because we don't have another or we still have 0 apple because we don't have another apple to sell as user two. So that order gets rejected. It is not valid. So these are the 4 commands we've run so far, and you can see that that 4th command didn't pass through to the matching service and didn't pass through to the settlement service because it was not a valid order. So now we are going to just show that if we are user three and we try to buy Google, user three only has $50. So they don't have enough to buy Google stock. So we send the order in and we see that that also gets rejected. And this gives us some information. This one was rejected because of insufficient shares. This one was rejected because of insufficient funds. So it's basically able to look at how many funds and how many what stocks the user has and see if they are valid. It's worth noting that again, to limit the scope of this, I don't have a queue flusher, so rejected items are put on the queue until the queue is flushed manually, just to sort of limit the scope of this again. So I can manually purge the queue and it will get rid of those rejected ones because uh, there's no user that accepts those queues, so it never gets passed anywhere, so it stays there forever. But you can see how the messages are sent from here on our orders API from our user, and they are invoked into the RabbitMQ messaging service where you can see we are receiving messages, and the messages are then passed on through these 3 Python workers to eventually fill out the Postgres database. And say we run a simple query here and we look at users and we look at their cache amounts um, right in here, and we look at users and we run that, we should see, yep, it has updated in our Postgres database. This was to reflect the 1 Apple stock. And say I were to, as user one, I go in and in the exec, I go and I want to buy 4 Microsoft stock. I just need to edit this to be 4. And that should go through risk. It is accepted, Microsoft stock is bought, it is filled, and it is changed in the database. And now if we run this again, we can see the dollar amounts have changed for user one and management. And if we look at positions as well, we should be able to see the positions have changed. So now user one does have 4 Microsoft stock. So that is the end of this demo.